Hey everybody, this is Mr. Beckstrom, and today I'm doing an example from section 10.4. This is find the center, transverse axis, vertices, foci, and asymptotes, and graph the equation. Alright, now the first thing is it doesn't tell us which one of the curves we're to be graphing here. Now we've been working on circles, parabolas, hyperbolas, and ellipses. So just kind of looking at it, the fact that they're asking for the transverse axis, which is the axis that's going to be parallel to either the x or the y axis. The only one that uses that term is the hyperbola. So I'm assuming this is a hyperbola right now. And considering that my x squared term is positive and my y squared term is negative, that means the x will become before the y once we get into the correct form. I'm guessing that this is going to end up having a transverse axis parallel to the x-axis. Now if I end up getting a negative on the right hand side and I have to multiply everything by a negative, then that's going to reverse this. So I don't know quite for sure until I put it into the correct form. So let's go ahead and complete the square and put these into the correct form. The correct form for these are on page 683, and it gives you the two forms depending on whether the transverse axis is parallel to the x-axis or to the y-axis. Alright, so let's go ahead and get started here. Completing the square is going to be a little bit tricky, so you have to be careful. So what we want to do is start with the x squared, and we're going to put the x term there, minus 4x. And then I'm going to leave a blank here because I have to add some number to complete the square. And then we're going to do the y's here. So I'm going to start with the negative 9y squared, but I'm going to factor out the negative 9 here because I really just want to complete the square using a 1 coefficient for the y squared. So that's going to end up being y squared. Now normally I have minus 18y, but I'm factoring out a negative 9. So negative 18 divided by negative 9 is positive 2. So this becomes a plus 2y. And then I'm going to add some number here to complete the square. And then I'm going to add 9 to both sides, so this is going to end up being equal to 9. So this is how I set it up in order to complete the square. Remember, you always have to factor out the coefficient in front of the x squared and the y squared terms to make it work right. If you don't, it becomes a lot more complicated. Alright, so to complete the square, we always take the number that is the coefficient in front of the variable raised to the first power. We divide that coefficient by 2, and then we square it. So I'm going to take the negative 4 divided by 2 is negative 2, and negative 2 squared is 4. So I'm going to add 4 here in order to complete that square, which means I'm going to have to go ahead and add a 4 over here, since I'm adding a 4 to both sides. And then over here, we're going to take the 2, the positive 2, and do the same thing. Divide it by 2. You're going to get 1, and 1 squared is 1. So I have to add a 1 here. Now I'm really not adding a 1 to this side because I have to distribute that 1 back out to see what I'm really adding or subtracting. So I have to multiply this 1 by the negative 9 on the outside before I do anything to the right side. So 1 times negative 9 is negative 9. So I'm really subtracting a negative 9 from this side, which means I also have to subtract a negative 9 from this side. So it should look like this, and once we get it there, we are going to have x squared, oops, not x squared, we're going to have x, and then use the first number that we got when we were completing the square, so this number divided by 2, so that's negative 2, so x minus 2, quantity squared. This is why we added that specific number, because it lets us turn that quadratic into a binomial squared term, which is what we need for our formula. And then we're going to have the minus 9 here, and then over here it's going to be the first number that we got when we divided this 2 by 2, so that's a positive 1. So I'm going to have y plus 1 quantity squared, and that's going to be equal to, well, the 9's cancel out, and I just have a 4 on this side. Alright, I'm getting close, but for the formula, this here needs to be a 1. Therefore, I'm going to divide it by 4, and if I do that, I have to divide everything by 4. Alright, so this becomes x minus 2 quantity squared. And I'm going to write that 4 as a 2 squared just so it fits my formula real nice. And then I know that a is going to be 2. And then minus. This is a little bit trickier. I really want to write this so there's no coefficient out in front of this y plus 1 squared term. So I'm going to do a little bit of a trick here, and that's I'm going to divide the top and the bottom by 9, which I can do. And that'll get rid of the 9 up here, and then I just have to divide that 4 by 9, so I'll just leave that as 4/9. So this is going to be y plus 1 quantity squared, and just like I did over here, I can write 4/9. I'll do this off to the side. 4/9. If I take the square root of that, take the square root of the top and square root of the bottom, so I can write it as something squared that becomes 2 over 3 quantity squared. So this is going to end up being on the bottom 2 over 3 quantity squared, and this is equal to 1. Alright, so now I have done all the hard work here, and it's really just kind of solving for C and then identifying what these are and then doing a little bit of graphing. Alright, so A is going to be the value that's being squared under the x term, so that's going to be A is equal to 2. B is going to just be equal to 2/3. And to find C, I have a little formula for that, and that is, in the book it's b squared is equal to c squared minus a squared. I'm just going to add the a squared to both sides so I can solve for c squared. So that means c squared is going to be equal to a squared plus b squared. And then I just have to solve that to find my c. So c squared is equal to a squared is 4. And b squared is 4 over 9, so plus 4/9. And that's c squared is equal to, 4 can be written as 36 over 9. So 36 over 9 plus 4 over 9 is 40 over 9. And then I will give myself a little bit more room. Take the square root of both sides. Remember, I'm only looking for the positive value of a, b, and c. And that's the square root of 40 over 9, which I can write as the square root of 40 over the square root of 9. And that's going to be 40. I can factor that as 4 times 10. So I can pull out the 4, so that becomes 2 root 10. All over, that's not a very good 9 there, but all over the square root of 9, which is 3. So this here is my C that I'm going to use. Okay, so let's go back and see what we're trying to find. So the center, just using the formula, remember it's x minus h and y minus k. So since we have a minus sign in that formula, it's going to be the opposite signs of whatever's here. So instead of -2, it'll be 2, and instead of 1, it'll be -1. So HK, or the, so the center is equal to 2, -1. And that's going to be the center of the hyperbola. And the transverse axis, like we kind of said before, is going to be the x-axis because the x term comes first. You have to be careful though, because if we ended up getting a negative on this side, then those would be reversed and the transverse axis would have been the y because the y would have come first. We just need to put the positive 1 first and then the -1 second here. If they both turn out positive, then you don't have a hyperbola, you have an ellipse. Alright, so transverse axis. So transverse axis is the x-axis, right? It's parallel to x-axis, x-axis. We want to find the vertices. Alright, so let me just kind of do a quick graph of this. So we know that the center is at 2, -1, So 1, 2, and negative 1. So this is where the center is. And the vertices use our A value. So what we're going to do for that is our A value is 2. So we're going to have it 2 units to the right and 2 units to the left. And that's because the transverse axis is parallel to the x-axis, and it goes through the center and the vertices. So all I'm going to do here is add 2 to this x value of the center and subtract 2 to the x value of the center. So the vertices are equal to, so 2 plus 2 is 4, so 4, negative 1. And also 2 minus the A, or 2 minus 2, is going to be 0, so 0, negative 1. Alright, so that's going to be here, and 2 out here. So this thing is a left and right opening hyperbola, and without getting the x-intercepts or anything yet, it's going to look something like this. Something like this. Alright. The foci, they're a distance from the center equal to C. So they're also going to be somewhere in the kind of the bowls of this hyperbola. So you'll have one over here and one over here. And to find that, we do the same kind of thing we did for the vertices, except we're going to use the C. So the foci are equal to, so if we take 2 plus our C, which is 2 root 2 over 3, that'll be the x value of our right foci. So that's going to be 2 plus 2 root 10, and I can just leave it just like this. And then we're going to have the same y value, negative 1. And then we're going to do the same thing. We're going to do that x value minus our C. That's the one on the left, over 3, and same y value is negative 1. Alright, so let's kind of figure out how far that is. So if I do 2 root 3, there we go, 2 root 3 divided by 3, that's about a little over 1. So that's a little over 1 from this x value here. So I'm going to go out, if this is 5 here, one of them is just a little bit past that 5, and this is negative 1. It's just going to be a little bit past that negative 1, and those are going to be my 2 foci. Alright, and then the last thing it says is, well, before we graph it, is they want the asymptotes. So the asymptotes are, what did I do? I'll make sure I put that in the right spot. That's weird. Alright, the asymptotes are the lines that go through the center that kind of show us where this hyperbola is tending towards. So as the hyperbola goes farther and farther to the right, it's going to get closer and closer to this negatively sloped asymptote here and this positively sloped asymptote here, and the same thing for this side right here. So in order to find the slope, notice that it is from the center here, it is going up in the B direction, and it is going to the right or to the left in the A direction. And the slope of something is the rise over the run. So in this case, since the rise corresponds to our B, that's our slopes are going to be equal to plus or minus B over A. So we're going to have two slopes, one for the positively sloped asymptote and one for the negatively sloped asymptote. So in this case, it's plus or minus. B is 2 over 3, and A is 2. And then I can just multiply by the reciprocal of the denominator. So times 1/2. 2's will cancel out. And that just gives me a plus or minus 1/3. So I can use this slope with any 2 points in order to write my asymptotes there. So pick a point and then pick one of these slopes, put it in. So for example, give me just a second here. I don't know why I keep writing on here. So notice that both of these asymptotes go through the center, which the center is 2, -1. So with this point here and each one of these here, I can set up my asymptote. So I'll call the positively sloped one y1, and that's just going to be y minus this y value here at the center. So that's going to be y plus 1 is equal to our slope. We said this is going to be the positively sloped one, and then we have x minus the x value here. So you can just leave it just like that for now, or you can distribute through and solve for y to get it in y-intercept form if you want to do it that way as well. And y2 is going to be the exact same thing except with a negative slope. So y plus 1 is equal to -1/3 x minus 2. And if we wanted to shorthand that, we could just write it with a plus or minus -1/3, or plus or minus 1/3 to show both of those. All right, and then this here is the graph, and it's going to look something like this. So when you match it up, the center should be in the 4th quadrant. The transverse axis is This is the horizontal line that's going to be parallel to the x-axis. That's going to end up going through actually the foci, the center. I think I moved this, shifted this a little bit up, but the axis here, the transverse axis, should go through both the foci, both the vertices, and the center. And this is left and right. All right, guys. I know this was a long one. I appreciate you sticking with me. If you have any questions, please let me know, but hopefully we got everything cleared. And remember, if you go to the table on page 683, once you put it into that form, it'll show you how to find the foci, the vertices, the transverse axis, the center, and the asymptotes. So it'll do all of that for you in just that little formula. All right, guys, have a great rest of your week, and good luck on the test on Tuesday. Thanks.